Okay, are you ready to roll? All right, you're on quadratics number 12. There's a boatload of quadratics. More than 20. I think it's 22 or something. Okay, lessons. That's way too long for a unit, but it just kept going, and so I don't know what to do. So we're on 12. So here's what the title of this one is. Vertex and line of symmetry. Everybody say vertex. Do you know what it is in the context of a quadratic yet? Have you heard it before? Okay, I've got some heard it befores. Are you with me? So let's talk about what the vertex is. How about the line of symmetry? Couple things in that, right? Line. Do you know what a line is? How about symmetry? You remember symmetry? If you had to explain symmetry, what would come up? Well, how could you explain it? Both sides are the same. That's pretty darn good. Okay, that's symmetry. And I always like to talk about symmetry in math versus symmetry in life. Okay, so symmetry in math is if you cut it in half and fold it over, it's exactly on itself. We're going to do it in the context of a parabola. So it's a quick drawing. It's not going to be symmetrical because I'm freehanding it, right? Here's the vertex and here's the parabola. Everybody say parabola. Right? And how do you spell it? Parabola. Okay? That's how you spell it, but we pronounce it parabola, right? But you say it, but you spell it parabola. I like that too because it sounds funny. Okay, anyway. So here's the vertex. The vertex is the point at which, if you think about this coming down, see how it's coming down? And now all of a sudden it's going up. Right here, it's going neither up nor down. It's flat. If you drew a line across the vertex, it's going to be a horizontal line. Because right then, the parabola is transitioning from down. It's transitioning from down to flat to up. Are you with me? It changes direction. And this is important later in your math career because you're going to be looking at graphs that go like this. And you're going to be saying, where does it change direction? It changes direction here and here. And at those points, the tangent to the curve is flat. It's horizontal. Are you with me? So that's what the vertex is. All right, so this is vertex. And here's line of symmetry. And I'm trying to draw a center line like they do in drafting. In drafting, there's a certain type of line that tells you it's the center of the shape. Right? That's a center line. Fair enough? And they call it line of symmetry. Line of symmetry. Right? So, I drew one on my paper. The theory is, and I drew it freehand, if I fold on the line of symmetry, right here, and you could see through the paper, which I can see because the light's over there, you probably can't see. My drawing isn't perfect, but the two line up and are on top of each other exactly. That's symmetry in math, right? Okay, so now contrast it with symmetry in life. If you cut an apple in half, is one side exactly equal to the other? Sometimes. No. I got some sometimes and no's. Why is it not? Some of the people that say no, why are you saying no? It's hard to cut perfectly. Fair enough. Any other thing of why it wouldn't be? Okay, how about this? Take my human body. Now this is a little bit different from the apple, but kind of the same idea. Cut me in half and fold me over. Does one half exactly line up with the other? No, I see a lot of no's now. Why? What's going on now?
One arm's bigger than the other.
One arm's bigger than the other. Right? Your arms are different size. They're different lengths. Your legs are different lengths. That's the whole cool thing about our bodies is they're so infinitely unique. There is no idea of symmetry. And parts of our body are off center. Is your heart exactly in the middle of your chest? It's somewhere over here, they tell me, right? I guess I don't totally know. I'm assuming they're right. It's somewhere in here, right? So, but we get the idea in general of our bodies being symmetrical in that there's an arm on one side and an arm on the other, right? So there's symmetry in terms of your general understanding of it, and there's symmetry in terms of math, which in math we can construct this unreal world. This is an artificial world, right? Is there anything in real life that's exactly symmetrical? I don't think so. This concept exists in your mind, and we have tools to illustrate it, but this is not a reality concept, right? We've done this before. We've gone through ideas in math where they only exist in your mind. And in fact, your mind is far more powerful than the real world, right? You can live your whole life in the real world, in your mind, other than the real world, right? Have you heard those stories of prisoners of war that were kept, right, in jail for years? There's some that tell stories that, I remember one, I forget which book I was reading, where he said that he deconstructed a motorcycle in his mind and rebuilt it one piece at a time in his mind. He just went into his mind and lived a whole life in there because the outside was so brutal, right? Are you with me? Our minds are like that. There's far more excitement going on in our minds than in the real world, in most cases. Okay, anyway, off topic a little, but you get the idea of the difference between symmetry in math and symmetry in life, right? There's this idea of you can understand the difference between them. Okay, let's get down to this. Let's take an example. Let me go a little bit quicker. The x location of the vertex is defined by negative b over 2a. So, x equals negative b over 2a. What does this mean? What are we even talking about? We have a function, let's use this one, f of x equals x squared plus 8x plus 15. By the way, if we factored that, what would we get? If you factored this, what would you get? Are you able to do those in your mind yet? You able to factor them in your mind? Remember, it's the reverse of FOIL. Right? So whatever you come up with here, if you FOIL it, you're going to this, right? That's what factoring is. It's a form of division, a form of separating back to a base, and then this would be a form of multiplying FOIL, the 4 steps of the quadratic. Well, I've got an x here, and I don't want to belabor this because we've done it before. 3 times 5 is 15, and 3 plus 5 is 8. Fair enough? So I know how to do the factoring because in my mind I can go 3 times 5 is a positive 15. A 3x and a 5x will now add to the 8x. See how quickly I can do the FOIL? That's where you're headed if you want to stay in math longer, right? In Algebra 2, they're going to kind of expect you to be able to run through that quickly. It's a little bit easier when you see it, and this one's kind of a straightforward one, so it's not too badly for us. How about the roots? If this is equal to 0, what's one root? X equals minus 3 because you put it equal to 0, and just see our other lessons. We've done this, so I'm running through a bunch of lessons to get to this one. And this one's going to reverse, and it's going to be x equals minus 5. So we know that this parabola is doing what? Minus 3, minus 5. So 1, 2, 3, 4, 5. 1, 2. Oh, I should have drawn those closer. She is. I can. Thanks. Who's that? Bridget's right here. And Ashley, they're asking for you in the college corner. Okay. Okay, stay with me here. You're talking about minus 3 and minus 5. So minus 1, 2, 3, minus 5. Here's the parabola, something like this. But I don't know where this is yet. Question mark. What's this called down here? Yes, did you just say vertex? Did somebody say vertex? Thank you, thank you. Okay, sorry for all the interruptions, you guys. Okay, so here I am at the roots, minus 3, minus 5 right here. But I don't know anything about the vertex. I have this formula for the x value of the vertex. A, B, and C stands for what? A equals, B equals, and C equals. I'm sorry, guys, for all the interruptions. Do your best to focus up here. What's A? What's B? And what's C? Search your memory. We've done it before. Okay, here's the help. A. x squared plus bx plus c equals 0. This is your generic quadratic. Generic quadratic. Quadratic. There we go. All right. What's a? Close. I know you want to say x, but the a sits in front of the x. Good. Thank you. Very good. Thank you. Good recovery. Nice. Appreciate it. Yeah, I appreciate you thinking through that, right? And I appreciate you letting me say no to you. It's awfully harsh sometimes. I apologize for that, okay? Because I'm like, no. Okay. B is, you with me? You guys see? B is 8. You remember it? All right, we've done it before. And then go for C. 15. Everybody say 15, right? So that's the way these things map out in a generic format. A is the coefficient in front of the x squared. So for that to be just an x squared, it has to be 1 times that. So very good on that. That's actually more difficult than these, where it's easier to see the 8 sitting in front of the x, and it's easier to see the constant sitting there, the c. And I'm glad they named c constant, because that's kind of appropriate. Take this, x equals negative b over 2a. Does it make sense to you that this would be negative 8, because b is positive 8, and there's a negative in the formula, over 2 times a, which is, good. So what is the value of x? Two times 1 is 2. Negative 8 divided by 2? 4. And negative divided by positive is? Negative, right? Remember that? Negative times negative is a positive, and negative times positive is a negative. Remember those? The strange thing is it follows English rules. Remember that negative times negative equals positive. In English, you know how you're not allowed to use a double negative? Does that sound familiar? Okay, if I tell you you can't not go to the party. You can't not go. How many negatives am I using?
2.
What am I really telling you to do? Go to the party. It works in English also. The double negative and the double negative work in math and English, which I always found was fantastic, right? When I realized that that was true. Okay, so you can't not go to the party means you have to go. Okay, so anyway, this comes out to be negative 4. Put that in here. That's showing you the x value of the vertex. It's right here at negative 4. Does that make sense to you, given that I've got a parabola going crossing the x-axis at negative 3 and negative 5? Now I'm at negative 4. Once we have the x value for the vertex, we now can plug that into the original function. So we say that y equals x squared plus 8x plus 15. Y equals, we have the x value of negative 4. Negative 4 squared. See how I plugged in negative 4 for the x? Plus 8 times negative 4, right? 8 times negative 4, plug in the x. Plus 15. And now do the math, and we're going to figure out what the y value is. Y value will tell us the height of the vertex. We know that the x is negative 4 here from here. What's negative 4 squared? Why is it positive? Thank you. Don't take this the wrong way, but I love you. Okay, so very good. Very good. Negative times negative is positive. You with me? And 4 times 4 is 16, so you get a positive 16. Okay, what happens to 8 times negative 4? Minus 32 here, right? Because this is a negative times a positive. And we have a plus 15 here. All right, can we do this math? Interestingly enough, this is positive and this is positive. And if we combine them, don't we get a positive 31? So a positive 31 minus a 32 is a negative 1. So now we have an x, we have a coordinate value, right? Remember, parentheses x, negative 4, comma, y, -1. So we go back 4 on the x, which we already did, and we drop down 1. This is actually right here. So look, I drew my parabola wrong because I was guessing. What's really happening with this is it's going like this. And it's going through this point right here, -4, -1. This is the location of the vertex. Okay, repeat after me. Oh. No, I get nothing today, huh? Nothing, but look how cool. Now you know where the parabola is changing direction right there, right? Before we avoided this. Remember we were focusing on roots and all those different things. Now we're actually looking at where is that vertex. It's a multi-step process. You got to find an x first. Then you got to plug that back into the original to find the y. It's difficult for us to do multiple steps, right? It's a multiple step process to find the location of the vertex. Okay, that's pretty much it for this, and that's a lot in one. It's a lot in one round. So let's see what I covered. The line of symmetry is the line about which a parabola can be folded onto itself perfectly. Good, so that's the line of symmetry. The vertex, the point at which a parabola changes direction. Thank you very much for that, nice. And function, another name for an equation, okay? Function, another name for equation. Function notation right here. Everybody say f of x. When you see this, I can basically, with some parameters, I can just change out the f of x for the y. Did you see me do that? I didn't explain it much. This is function notation where f of x equals our trinomial. I can replace it with a y because it's on the xy coordinate plane, right? This is an x here, this is a y. Those are those axes. And you're in a two-dimensional plane, x and y. What's the third dimension in the Cartesian coordinate system? Z. And finally it makes sense, x, y, z. So this is a little bit off topic, but for next year, right? You've got x and y, that's your two dimensions. You'll also have something coming out at you, the third dimension, like a 3D movie, z. Okay, the third. Okay.